All right, you got your piece of paper, yes? Okay, so I have it landscape, right? For using computer vocabulary, we've got it landscape, okay? First thing I want you to do is take the top and fold it down, but only like about that much. See how much? Can you tell how much? Like an inch, inch and a half, something like that. Doesn't have to be exact, okay? But somewhere around there. Yep, that's good. Now, while it is still folded, we're going to use our brains, right? While it's still folded, I'm going to take my pencil, and I'm going to draw a line so that I have a beautiful straight line. Isn't that nice? I'm not trying to follow the crack when it's open. I leave it closed and got it? You're strange sounding. Okay, everybody good so far? All right, now I want you to take the right-hand side of the paper, and I want you to fold it over, about a third-ish. I want you to crease it, and we're going to draw another line, but this time we're not going to draw the whole line. We're only going to start right there so that we have something that kind of looks like a table. Does that make sense? Yes or no? Good. So I folded the top, and then I drew the line, and then unfolded it. I folded the side, and then drew the line, but only started where the other line stops, right? Everybody okay so far? Okay. Now, what are we talking about today? Domains and ranges, right? You know that because it says it on the board, and you already wrote it down in your notebook, right? So we're talking about domains and ranges. I'm not going to write the word domain or range on this paper at all. Is that weird? Before we can start talking about domains and ranges, I need to make sure that we have a common vocabulary. I need to be able to talk about certain numbers being integers or certain numbers being whole numbers, and you know the difference between those two things. Because right now I'm afraid that you do not. I'm not judging. I'm just trying to help you increase your vocabulary. Is that fair? Okay, so let's build vocabulary first, and then we'll talk about domains and ranges. Got it? Okay, so this little chart foldable thing that we're making today is all about numbers. Specifically, this table that we're making today is all about real numbers. Got it? Now, we use a specific symbol for real numbers, don't we? What symbol is that? So it's an R, right? Earlier, some people were describing it as IR. And I can see where that comes from, but please understand it's not an IR, right? It's just an R, but the left-hand side has like two legs. God bless you. So like that, right? That's the all real number symbol, right? Everybody okay with that? You've seen that before, right? That's familiar, isn't it? Okay. So let's go to this big side right here. Notice how there's like a big side on the left and a smaller side on the right. We're going to start on the big side on the left. Okay? Now, the smallest set of numbers here on the left, I'll make a little oval right in the middle. Want me to zoom in a little bit? Yeah. These are called natural numbers. Sometimes they're called counting numbers because they're the numbers that we learn to count, right? So natural numbers would be 1, 2, 3, and so on. Okay? There's a symbol that we use for natural numbers. What do you think it might be? Some sort of fancy N? That is a very good guess. Fancy fancy N it is. It's a fancy N, right? It's like, maybe if I make that leg a little darker and that leg a little darker, now does it look more like an N? Is that good? Now, including all of the natural numbers, plus more, are whole numbers. Is 3 a whole number? Yes, because why? It's inside that oval, right? Now, is 3 a natural number? Yes, for sure, but it's also a whole number, right? Okay. Now, what is a number that is a whole number that is not a natural number? What'd you say? Good guess. I want that answer in just a second. That's the only one. There's only one whole number that's not a natural number, and that number is 0. Okay? 7 is a natural number, isn't it? 7 is a whole number, isn't it? The only number that is a whole number that's not a natural number is 0. Everybody okay with that? Okay, now including whole numbers and natural numbers, there's another set of numbers called integers. I want you to think before you answer this, okay? What symbol do we use for integers? Now, I noticed nobody said really fast a fancy I, right? Why would that not make sense? Yeah, I's look a whole lot like ones, don't they? So I's would not be a good choice. Okay? So naturally, obviously, it's a Z. I know, I'm just being silly. It's okay. It's not obvious at all, right? Some people say, oh, I get it, integers. And I'm like, no. But good try. Good try. Okay? Oh, yeah, it sure does. I forgot about it. Can we add it real quick? Does whole numbers have one? What is it? What do you think? Yeah, W, right? A fancy W. So dun, 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 dun. It's just a fancy W, right? Any questions? So give me some examples of integers that are not whole numbers. -2. What else? -1. What else? So basically any negative whole number, any negative natural number. I don't want to say whole number because there's not really a -0, is there? Okay. Oh, that's a good question. Can you wait just a second? Okay. Any question about an integer? Give me 3 more examples of integers that we're not going to write down. -1/2 is not an integer. -1/2 is not an integer, for the record. What'd you say? Nope. -4, -10, -7. Does everybody see the grouping of the ones that I said were integers and then the ones that I said nope, nope, nope? We good with that? Are we clear on what an integer is? I'm afraid, so I need 3 more. -11, -20, and -47. Are we okay with that? -5,000 is also an integer. Okay? Now, nobody said anything like this. 6. Is 6 an integer? Yes, right? 6 is also, what, a natural number, so it's a whole number, so it is an integer because it's inside of all of that. Does that make sense? Okay. Now, the last part of this side, this like rectangle-ish, squarish shape right here, right? Pretty sure it's a rectangle, but I don't want to have to measure right now. These are all called rational numbers. That whole section is called rational numbers. Guys, what is a rational number? You're on the right track. Look. which is another word for fraction. Okay? A rational number is a number that can be written as a fraction. So I need an example. 1/4, 1/2, 1/3. Except nobody said anything like 0.5 or 0.25. Can those be written as fractions? Yes. So now I have to ask you a trick question. What about this? 0.3 repeating. Oh, so it's not really that much of a trick at all, is it? Because you know 0.3 repeating is 1/3, and that can be written as a fraction, so it is a rational number. Okay? So if this is rational, oh, what's our symbol? What's our symbol for rational? This is a fancy R. It can't be a fancy R for real and for rational. So choose the next most obvious letter. You know, Q. You guessed. It was a good guess. Is it obvious? No, I was being silly. Okay. Fancy Q is irrational. Got it? So if these are rational numbers and they are numbers that can be written as a fraction, what is this? That's exactly right. Irrational. And an irrational number then is one that can what? Hold on. Answer my question first and then I'll answer that question. What is an irrational number? A number that can not be written as a fraction. Does that make sense? A rational number can be written as a fraction. An irrational number cannot be written as a fraction. So I need some examples. That's the most popular one, right? Pi is the most popular one. Here's another one that's quite popular, but here's my favorite. I know your whole life that people have told you that's a letter. That's because it is. In math, we use it to represent a very specific number. But it is irrational because you can't write it as a fraction. Oh, it's not time for that. That's some foreshadowing. All right, now you have something to look forward to. That is a good question. And you're like the fourth person that's asked me that today, and it's a good question. But infinity is not really a number. Does that make sense? It's a symbol that we use to recognize like all the way one way or all the way the other. It's not really a number. But if the definition is I can't write it as a fraction, it fits that definition, doesn't it? But since it's not an actual number, it's just a representation of a number, we're just going to stay out of the argument. I think there's mathematicians that argue about it. I am not one of them. Okay, we're just going to stay out of that argument. Is that okay? Okay. Okay, now, Landon, ask me your question again. I think if I heard you right, what you said is, so are irrational numbers real numbers? Is that what you asked? Okay, so help me answer. Are irrational numbers real numbers? Yeah, because they're all underneath the real number title, right? Okay. Now, there's always someone who says to me, ha 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 ha, real numbers. What does that mean? There's fake numbers? Ha ha ha. It's not time for that discussion yet. Also foreshadowing, also something to look forward to. Okay. How do you feel about especially these vocabulary words that we just talked about? If I give you a number, could you classify it? Okay, my favorite number, 13. Classify it for me. It is natural. It is whole. It is an integer. And it is rational. It's all those things, right? What about negative 13? Only an integer and rational, right? Does that make sense? Okay. Any questions? We good? I'm feeling confident. Are you feeling confident? And the reason I'm feeling confident is because your answers. You're not sitting there staring at me like I have four heads. Okay. Which I'll tell you right now will happen at some point this year, and that's okay. Well, I'll talk you through it. Okay. Any questions? We're good? Okay. So if we'll take just a couple minutes, if one person from each table group would collect the table groups and then bring it back here to the punch holder and punch it this way. Does that make sense? Punch it this way. If one person from each table group will do that, I'm going to pass out our worksheets for the day. Thank you. Hey, can I scoot behind you real quick? Thank you. There you go. There you go. You are welcome. There you go. You're welcome. There you go. You're welcome. And there you go. You're welcome. So what we just did, that's a great question. What we just did should be the second thing in your notes section. Okay? The first thing in your notes section should be the parent function worksheet, right? And then this should be the second thing in your notebook. Yes, what's up? It does not. And that's also a very good question, okay? It doesn't matter to me if you go like earliest to latest or if you go latest to earliest. I just need it in order. I don't know, the one that says notes. See, 1, 2, 3. Yeah. I'm behind you. Thank you. Okay, does everybody have a worksheet? Yeah, I just gave it to you. Yep, this is your homework for the day. Yep, it is. Now, please notice here at the top, even though there's a punch hole right through the first part of the word, you can still tell what it says, right? This is our examples. I don't remember what you mean. I'm sorry. Yes, we'll talk about that in just a second. Yes, thank you. It's right here. I'll remember to tell you in just a second. Okay. Okay, so notice the first 6 we're going to do all together. These are examples. Okay. So let's talk about the first 6 and then we'll talk about the rest of the worksheet. I'm going to zoom in a little bit so you can see very clearly what's on my page, even though it's on the page right in front of your face. That's okay. We want to be able to see this together. Yes? Okay. Now, remind me vocabulary word domain. X values. Remind me vocabulary word range. Y values. And remind me vocabulary word function. How do you decide if something's a function or not? Vertical line test, right? We slide our vertical line. It could be our pencil, it could be our pen, but we're using pencil for notes unless we're color coding, right? We're sliding it across. How many times is it allowed to touch the graph? Once. Okay? All right, we'll get there in just a second though. Let's think about this. This first example, I'm going to write the domain and range in interval notation. Okay? Remember, we have to, in Algebra 2, we have to write interval notation, inequality notation, and set builder notation. You remember that? Okay? Yeah, sure. Okay. So I'm going to make sure we have covered all of those today. Okay? Interval notation, that's with the brackets and the parentheses. Okay? So if I'm saying, what is my domain? Well, how far left and how far right does this go? Another way some people do is they cover up anything that they can't, like that's nothing is there. What X values can you see? 2 to 4, right? Is 2 included as part of my domain? Yes. Is 4 included as part of my domain? I've heard some yeses and some nos. I'll tell you right now, one of those is the correct answer. Okay. Why do you think it's no? Oh, it's an open circle, right? It's not a filled in dot. So the 4 is not part of the domain. Yep. If it is part, you put a bracket. Okay. What about the range? How far down and how far up? Or we could cover up. Oh, we had to fight about this. Okay, 2 to -2. That's what I heard. Why? Why did you change your mind? Down to up, right? Remember we talked about that? Good catch. Excellent catch. Okay, so -2 to +2. Is -2 included? Is +2 included? Is it a function? How many times is it touching right here? Right there and right there, right? It's touching twice, so that is not a function. Last period wanted to write absolutely not. If you want to write that, that's fine. I'm just going to write no. Okay? But also that meant I knew they were positive that they knew what the range, was a function or not, right? Any questions on this first example? What you got? You good? Are you lying? You are lying? Okay, awesome. We'll talk in a minute. What's up? What's up? Oh, okay, so I'm moving it across, right? And then what I'm trying to pay attention to is I'm trying to pay attention to like the thing that's graphed, okay, the thing on the graph. If I move my pencil across, how many times is it touching this right now? 1, 2. It's touching it in 2 places. If it touches it in more than one place, it is not a function. I just slide it over like that. If it ever touches in more than one place, it is not a function. Good question. Okay. All right. Are we good so far? We're pretending? Okay, awesome. All right. What about this one? What's my domain? It's kind of tricky, right? What are the only x values that are represented on this graph? -3 and +2. That's it, right? So, let's say set builder. Set builder notation. Here's how we have to do set builder notation. We have to use one of these pretty braces. Well, you don't have to whoa me. I'm not a horse. We're talking about domain, so we tell our reader we're talking about x's. Not only any specific x or any general x, but this is a vertical line. It's not a 1. It's not an L. It's a vertical line, and it means such that all the x's are either -2 or +3. Okay? There's no other x values but -2 and +3. So I just list them out. Okay? What's up? What did I say? Sorry. No. Good correction. Good correction. I told you in the very beginning of the year I'm not a robot, right? So good catch. No, that's fine. And that was a very polite way to correct me, so good job. Okay? All right, what about the range? How far down and how far up? Those are our y values. It does. To where? So if we were writing interval notation, it would be easy, -infinity to +infinity, right? We all know that. But we need to make sure we understand set builder notation. Set builder notation is very, very similar to inequality notation. It just has this fancy brace, and we're saying y, the horse, right? And then we're saying y such that it's all real numbers. Because that's what it would be if it was inequality notation, right? We'd just write all real numbers. Is it a function? How many times is my graph touching right here? All of them, right? Because it goes on forever here, so all of these points are touching my pencil right here. So is it a function? No. Correct. If the lines are vertical, it cannot be a function. Okay? You ready to go on? Okay, next one. Inequality. Is that what we want to do? Well, I just have a list of points. What's my domain if I'm just given a list of points? Yeah, it's just the x's, right? So 3, 5, 7, 8. It's just the x's. With the horse things, yes. What about the range? 6, 7. Do we write 7 twice? We do not. 6, 7, and 9. How do we tell by looking at a list of a list of points if it's a function? Which ones? If the x's repeat. Do any of the x's repeat? No. So is it a function? Yes. Do any of the y's repeat? Do we care? No, we do not. Not when we're deciding if it's a function or not. It's only if the x's repeat that we care. Okay? Any questions about this one? Good so far? All right, next example. Domain. How do you want to write the answer here? We have 3 choices: interval, set builder, inequality. Interval, okay? I'll just mark that down. Just so we keep our vocabulary in the front of our mind. Okay? So how far left and how far right does this go? -5 to 5. Is -5 included as part of the domain? How do you know that? It's a filled in circle, right? So, is the 5 included as part of our domain? What about the range? -3 to 2. Did I write them right that time? Okay, good. -3 to 2, how far down? Oh, I already said that. Is -3 included? Yes. Is 2 included? Is it a function? How do you know? As I slide my vertical line up across the page, how many times is it touching the thing that's graphed? Only one, every time. Okay? All right, look at this strange thing. I don't care. We can do interval again. Most of you seem to like interval the best. We should. So you want to do set builder? Set builder. I put the dot on the wrong whoosh. Sorry about that. What's my domain? X such that. How low does it go? It just stops at -5. And how far up does it go? +5, right? So X is between -5 and +5. Which one's included? The +5, so that's a less than or equal to. When we're doing when we're doing inequality or set builder, if it's included, it's or equal, and if it's not included, it's not or equal. Does that make sense? Okay. What about range? -2 to 2. So -2. I just always start like that and then go back and fill in my inequality or my or equal to if I need to. Is -2 included? And do you see why that might be confusing to some people? Because this is open, but this is closed, and that's a line. So is -2 part of my range? Because does this get all the way to -2? Yes. And does this get all the way to -2? Then it is included. And is +2 included? Yes or no? Yes. Is it a function? Yes. Okay, last one. Let's just do interval on this one too, please. How far left and how far right? Are -5 and -1 both included? Yes. What about the range? How far down and how far up? -2 and 2. Are -2 and 2 both included? Oh no. Which one's not included? -2, because there's an open circle right there. Is it a function? No. Okay. Now, I want you to notice that the rest of this worksheet, there's 27 questions. Okay. I need you to realize that if I hand you out a worksheet with 27 questions, very rarely will you ever have to do all of 27. Okay. So would you please circle the following questions? 2 and 3, 4 and 6, 2 and 3, 4 and 6, also 7 and 8. Go to the next page, please, and circle number 12 and 13. And then go to the last page, please, and circle 20, 24, and 26. 20, 24, and 26. Okay? I believe that's 11 questions that we circled. Okay? So what about the other 16? Unless you want extra credit. I told you yesterday when we talked about extra credit that I offer it sometimes, right? This is how I offer it. When I assign you a worksheet, I'm going to pick and choose specific ones that I want you to do because I think those are important. The rest of them are also important, but I'm giving you the option to do those for extra credit. Does everybody understand? Okay? Any questions before I stop recording?